134 degrees. So this angle, 15x minus 23, should be half of this arc, 134. Well, I can either do half of that or I can double both sides. I get a little bit bigger numbers if I multiply both sides by 2 here. So I'm just going to do half of 134, just 134 divided by 2, and that's 67. So my new equation is 15x minus 23 equals 67. And so now we solve for x by adding 23 to both sides. So 15x equals 90. 67 plus 23 is 90. And then we divide both sides by 15. And we get that x equals 6. All right, we're going to cover some more of these examples in class. We didn't get through a lot of examples, but we're using this as the basis for our information. We're going to set up one of these equations for every problem and then just use our algebra skills to solve those equations. So make sure you have watched the video and taken good notes. I hope you were listening well, and if you have any questions, please feel free to ask in class. Okay, we're going to do one or two more examples. There's a lot of examples in this notes packet that we're not going to cover in the video. We will talk about them in class, so don't just get rid of those yet. We're going to move on to this example. They're not numbered, so it's this bottom right corner of these 4. And we're going to, again, solve our problem to find what they ask for. In this case, they're just looking for the value of x. So instead of giving me just numbers like these last few did, they're giving me an algebraic expression. So we're going to look at angles that are either central angles, or they have a vertex on the circle, or they have a vertex inside the circle or outside the circle. Well, in this case, every vertex of every angle I have is on the circle. And so there's several different ways we can look at finding this value. And this goes back to a very similar problem that we had from the very first lesson, 6.1. We have this angle L that uses x. Okay, this is an inscribed angle. Our vertex is on the circle. So what that means is this angle measure is half the arc measure across from that angle. We call it a intercepted arc. And the intercepted arc that goes with angle L is arc OM, or MO. This entire arc from M to O. So that, whatever degrees that is, should be twice as much as this. Well, I can actually use the other given information to find out what that arc measure is, because I have these other two arcs, LO and LM. All three of these big arcs should add up to 360. I can ignore the fact that this is two separate arcs. I want that combined total. So this point N doesn't really even matter. So to find the measure of arc MO, we're going to do 360 minus 91 and 135. And that gives me, okay? So first of all, we're going to deal with this example here. And in this example, we want to look at where our angle is formed and where the vertex is. So that central or in, on, or out refers to where the vertex of the angle is. Well, point S is the vertex of your angle, and that is outside the circle. So we're going to be using this setup, that the angle measure is equal to half the difference of the arcs by subtracting the arcs. Okay, I'm even going to write that above. Okay, angle equals arc minus arc divided by 2. Okay, so we're just going to set this up using our two arcs here. Okay, QU is one arc, TR is another arc. There's the two arcs. I have the 46 degrees for arc TR, and I have the angle measure S. So instead of angle, I'm going to write my 35, and that is equal to arc minus arc. So I want to go big arc minus little arc. This arc QU, that should be an arc symbol. Arc QU is what I'm looking for. I can call that X. So X minus my other arc of 46, all divided by 2. Well, there's a couple ways I can go about this. Remember, rather than setting up your formula this way, I could just say 2 times the angle equals arc minus arc. And then I don't have that, sorry, arc minus arc. I don't have to have my fraction now. So I'm going to move this as a times 2 on the other side. So when I do that, I actually get 70 instead of 35, is the difference between the big arc, x, minus the 46-degree arc, tr. So all I have to do is add 46 to both sides. And 70 plus 46 is 116 degrees for arc QU, which we called x. Okay? So I would have arc 1 plus arc 2 divided by 2. And either all divided by 2 like this, or multiply it by 1/2, kind of like we did there. What that tells me then is, again, this is the average of the arcs. Okay? What I could also write then is that 2 times the angle measure is equal to the sum of the arcs. Okay? Rather than dealing with a 1/2 on this side, I make it a times 2 on this side. But we have one other possibility, and that is that if the angle is outside of the circle, and this would be either using tangents and or secants. Now there's several different cases we could use for this. I'm only going to show you one, and I'll show you some other cases in class, but case 1, meaning our first scenario, scenario 1, I could use that word too. Okay, that is going to be 2 secants, all right? So if I have a secant here, and another secant that intersects outside, I didn't draw the other one long enough. There we go. Okay, if I have those 2 secants, they create this angle outside of my circle. If I call that my x, we have these other 2 arcs that we're using. So I still have 2 arcs, but rather than adding the 2 arcs, when I move my angle outside of the circle, it inverts one of the relationships. And all that really means is now we have a negative arc measure to consider. And I'll explain more of why we think of it that way in class. You could also think of it like this, that the angle measure is equal to, we're still going to divide by 2, but instead of adding the arcs, we subtract. Arc 1 minus arc 2. But really, we always want to do the bigger arc minus the smaller arc. You'll always have one that's bigger. They may both be minor arcs, but you will have one that is larger than the other. Okay? So we want to do large minus small and divide by 2. Like I said, rather than dealing with a fraction on this side, I could make it a times 2 on this side. 2 times the angle measure would have to equal the difference of the arcs. Arc 1 minus arc 2. And so we're going to use these formulas today to solve some problems based on whether or not the angle is on the circle, on, inside, or outside. Now we also have the idea that it is a central angle. Central angles are inside, but when that's exactly at the center, both of these arcs are exactly the same as their angles, so it all works out to be just angle equals arc. So let's try some examples. In this video for Unit 6, Day 3, or Day 6.3, we're going to take a look at the angle relationships formed by different lines, and where the vertices of these angles are determines how we relate angle measures to arc measures. Okay, so at the top of your notes here, I do want you to write this at the top, because this is kind of the main idea of what we're doing to build these equations today. Okay, we're going to relate angles to their corresponding arcs. Okay, and we're going to set up equations doing that. Now you may notice in the notes it says there's a quiz next class. That's not the quiz that you're going to want, or that you're going to be ready for this very next class, but after this lesson, the following class there'll be a quiz. So don't stress too much about that. I'll talk more about this in class. You'll get an extra class ahead of time to prepare for that. All right, so we are taking a look today at these different kinds of angles, or the angle measures rather, when we have angles that have a vertex either on the circle or inside the circle or outside the circle. So I'm going to draw some pictures to help go along with this. If you need to pause the video at any time to copy it down, please do so. Okay, I first want to just start with drawing a circle for when we have a measure of a central angle. This is from lesson 6.2. We talked about central angles previously, actually 6.1. Very first lesson we talked about central angles. And that's when the vertex of your angle is at the center of your circle. All right, if this angle is x degrees, this arc is x degrees. So in that case, the measure of a central angle, angle measure equals arc measure. All right? Just they're exactly the same as each other. Angle measure equals arc measure. Okay, we also looked at inscribed angles. That was also lesson 6.1. Okay, if I've got a circle and then I move this angle back here to where the vertex is on the circle, it's no longer angle measure equals arc measure. It is that the angle is half of the arc measure. So angle measure equals half of arc measure, or 2 times the angle measure equals the arc measure. These are both the same relationships, just focusing on either using a 1/2 on the arc measure side or a 2 on the angle measure side. And so we looked at how to find different measurements for either angles or arcs or both using those kind of relationships. All right? But now we're going to look at some different ways that we could use angles involved with circles. All right? And the first one we're going to look at is when the measure of an angle formed by 2 chords, that angle is inside the circle. So it would look kind of like this. So if I have a circle and I draw 2 intersecting chords that are not diameters, okay, and it would still work for diameters, but it's going to be a little bit different. So let's draw a chord here and another chord here. Well, that creates, first of all, 4 different angles, and so I'm only going to talk about one of them at a time, but each of these 4 angles has a corresponding vertical angle it would be congruent to. So if I talked about this angle here, it would be congruent to this angle. Well, what that does, if I call that x, it creates these 2 vertical arcs, and that's kind of a word that I've made up. I'm not sure if any other math teachers use that, but we have vertical angles, so these arcs on opposite sides could be considered vertical arcs. I'm going to call one of them arc 1, the other one arc 2. Okay, this is just a way of naming them. So what that does is it sets up this relationship where x depends on the measures of these 2 arcs. And so what we have here, our formula, is that this angle measure is the average of those 2 arcs. Well, to find an average, remember that we will add 2 things and divide by how many there are, in this case 2.